Okay, so keeping up with the topic of security audits and security in general, we will now have a panel talking about scalable ideas for reducing smart contract hacks in the next 3 years. And the 3 years is particularly important because we should get to that sooner rather than later. So today with us, we have Nebojsa from Tenderly, Nenad from DeFi Saver, and again, engineer, this time from Y Academy. I mean, we're all involved with multiple things. Mr. Moderator will present himself, and I'm leaving it to you boys to take it away. Please, applause.
Hi all, I'm Noah from Hacken. I'm a lead security auditor. They're working on Solidity and Rust audits, as well as leading a lot of the efforts in terms of standardization and best practices on security within the company. I have to say I am responsible for a lot of the improvements in the Hacken methodology, and that is my main sort of movement this year. And today we will be talking about all the security stuff. So what should we open up with?
That's a good question. Maybe the state of the current ecosystem and what we hate the most about like current
what
development.
we hate the most, maybe it's the best thing. Like
Yes.
we start off hating and then we can move to some.
Let's get that out. So I mean, clients can be pretty bad, but really they are only that bad because we allow them to be, right? I mean, most security auditing companies, they do not really enforce the best practices, right? We've been talking about a lot about the ways to measure everything, and I mentioned in my question, and it was mentioned also by another gentleman here, test coverage and such practices, but from what I know, most companies do not really enforce that for most projects. They are just like checking the current state of the affairs, the current state of bugs, but they do not make sure everything is going to be well in an ongoing manner. So what do you guys think about test coverage?
I think that every audit firm who's done more than 3 audits has seen a large variety of quality of code coming in. I mean, all of you that have met developers, I'm sure you know some developers who write amazing code and some that don't write so amazing code, unfortunately. I do find it very interesting that some firms, or some DeFi protocols, let's say specifically, have a really high bar internally for where they get the code quality to before they do an audit. To be honest, if we could have everyone setting such a high bar internally to their own DeFi protocols, that would be amazing. I think we would all enjoy the security field much better if the code we looked at was at that high level. So developers, remember to level up.
And I would say as for the test coverage, I mean, people are trying to ship things as fast as possible, and often they are like, let's not do the test right now, let's try and testing afterwards. And because of that, like most of the project, I think that are like trying to get to the production as fast as possible without like doing a proper set of like security aspects and checkings in place.
Well, but if you're doing tests afterwards, like, do you even have requirements ahead of time? Like, do you even know what you're building?
Well, I would say yes. I mean, like you can like build things in the beginning and then test later. Maybe like for some special edge cases, you're just like not thinking about them at the time, and just like later on, like when the contracts are deployed, like start thinking about them.
Oh wow, that's.
I mean, it's not good, but like we live in that kind of environment right now.
What do you think about like test-driven development as an approach?
Like I'm all for it, but as mentioned again, like
Hard to implement.
yeah. And I mean, as engineer said, like we have different levels of code quality coming in, and that's like one of the biggest problems in the space.
Yeah, I actually think like the auditing firms should be a lot harder on that, because as we all know, like from an application side, when we're looking at like what auditing firms are available and where we can find an audit and so on, usually it's overbooked. And it's just kind of, for the auditing firm, they kind of accept everything, and it's just a matter of like money and like timetable. I actually think they should have like kind of ranking of like, if this is better code, if this is like a highly tested, like an easily auditable code, actually code that's ready for an audit, that should have like a higher priority of actually like going into the audit pipeline. And for projects that ask for an audit and the auditor like assesses it's not ready yet, it should be kind of pushed back a little bit. I think the auditor should like tell the project like, hey, you first need to actually like test all the business logic, and then when you know that the whole code is actually working correctly, we can look at it from the security side.
Wait, but do you have like hard requirements then for what's going in, or do you still let it slip?
Yeah, so I mean, basically, I'm not talking from an auditor side, because we're more on the application side. We don't really do audits, but in my opinion, I guess it's kind of heuristic, like it's not like a hard metric, but auditing firms probably should have like a kind of a ranking system, at least internally, of like stuff we actually think is ready for an audit, and that's the stuff that's going to get priority to actually get audited.
What about, you know, the enemy of every tech guy, the sales department? I mean, yeah, I know we're not ready for an audit, but this is urgent. We'll pay you like $70 million.
Yeah, I don't have really a good solution for that. I mean, I think the engineers actually need to kind of push back a little bit on that. And like we're building, like a lot of times these are like financial apps. These are apps that are gonna hold a lot of money, that are gonna interact with a lot of value. So we actually need to be like really careful about it, because okay, we can push it this month, it's gonna be better, maybe we're gonna catch up to the competition or whatever, but if we get hacked 2 weeks later, it's all for nothing. So I think engineers need to like push back from the business development side that like security comes first when we're dealing with money and user funds.
I will actually take the devil's advocate perspective on that and say that when we talk about the blockchain space, often when we hear the word incentives, we think about tokenomics or the design of a DeFi protocol, but we have incentives in the security space too, and that is unfortunately to process as many code bases as you can. So even if we have some audit firms who do follow proper process, they have a checklist of requirements of what the code should meet before the audit begins, you're still going to have other firms, other solo auditors who don't have such processes, just because of the incentives. So unfortunately, we need better incentive design even here, ideally.
Well, I mean, the biggest incentive should be security, I guess.
I think a lot of security people and security firms in this space, unfortunately, are not necessarily prioritizing the overall security of the ecosystem, but more their own benefit. I think that's part of the problem I see with the incentives. One of the things I hate is the incentive design.
Okay. Okay. We've gotten some of that frustration out now. What do you think? What would you implement that would anger the customers the most, but you think would be like the most necessary thing in terms of improving security?
I will give an analogy instead of a direct answer. I'll let the rest of you speak for direct answers. Have any of you met a really, really privacy-centric person who doesn't use a cell phone, who uses some obscure operating system that doesn't support anything, and when you want to even send them an email, they're like, no, I don't use email, I use this protocol over here. I feel like that is the sort of thing that we could do in the security space to really level up the game, but it's just not realistic for the average person, unfortunately. So we have to somehow find a middle ground between the idealized end goal of security and what the average developer is willing to deal with. So I think the security people want it to be here, and then the developers want it to be here, and we need to find where is a good spot for that.
Maybe a good approach here, like, would be to look at it from the holistic perspective. Like, we're now talking about like securing some smart contracts on the network, but are there things that we can do to secure all of them? Currently, like, if we look at the smart contract landscape and the bytecode that represent them, they can be basically anything. Like, you can start running on the virtual machine basically anything, and there's no really easy way to like ensure that they are behaving in the way that something fishy can happen there. But like the way that people in the Ethereum ecosystem think about it is that we can like bring certain abstractions to the bytecode that can help us like better holistically check if there are any like malicious or vulnerabilities in the smart contracts. One of the pushes for that is the EVM object format that is going to determine how the bytecode is going to look like, and it's going to allow like for a more holistic approach for on the security of the whole chain. And that's one of the things that could really help us in securing like from the more holistic perspective.
Yeah, I kind of agree what was said earlier. Like it's always kind of two sides of the optimal security is probably like just not building a smart contract, right? So that's like the starting point. So it's always kind of a mashup. Like obviously the auditor would want to have it as simple as possible to have like totally tested, totally safe, simple code that's really easy to audit and everything else, while the developer on the other side is thinking about like all the features and all the requirements he wants to build. So it's always kind of finding the good middle ground. In general, I would say that like to improve general like security perspective, I would guess that like the developers actually need to be kind of more informed on not just like to write good code and write good tests, but also kind of to think like auditors. So for instance, every time we're writing some code, obviously it's hard to try and audit your own code. It doesn't really work that way. But we do try to kind of have, if it's kind of a code that's kind of new and we're kind of not sure of all the things that can go wrong, we do try and kind of do a small impromptu security audit before we actually contract an external security audit. So I actually think that developers need to be like semi-auditors themselves. They need to follow like the security ecosystem. If something like gets hacked, you need to kind of understand why it happened, because it might happen to you also. So I think kind of generally pushing that there isn't really two roles, like developers and auditors. Like it's even the auditor, I think in order to be a good auditor, you kind of have to understand the space really well. And in order to understand the space really well, you have to be a user, you have to be somebody that actually thinks about like how the protocol works at a low level, not just like what are some security issues that are common. Okay,
so for the developers and the audience, what are some good steps that they can do right now? They're coming home this evening and they're like, oh my God, I really don't want to get hacked. These guys scared me. What can they do right now? What can they set up right now to make their code better?
Yeah, that's a pretty hard question, but I would definitely like first start from the basics. Like, have you followed like the best practices we kind of all know in a sense that like, do we need to write a little bit better? Because you can have like tests that are okay, but you kind of know as a developer like this can be much better tested. So starting from the basics and then kind of seeing it from like starting to actually learn as a person that would audit or trying to hack something. Actually like going on a platform like Immunify and maybe picking a protocol and trying to like white hat hack it. I think that's kind of a valuable experience that then you can learn and kind of...
I mean, that has a bit of a high barrier to entry to go to a bug bounty. Like, what's something really simple, like, you know, one-click setup or like 20 minutes, 1 hour?
I mean, maybe even just running some sort of like a static analyzers on your code. If you haven't already, most likely it won't find anything serious, but it may be like point you in the right direction. And obviously, it's always good to check even the basic edge cases. So I would say like running some sort of a code analyzer. There's a few that's open source, so you can set it up, run it, and then kind of maybe go from there.
Okay, so like Slither and Mitchell and any other tools would be a quick step. Yeah, there's even like VS Code extension and probably something else for Slither. But do make sure to update to the latest version, because we just bumped up to 0.9, which is way better. Okay, engineer, what do you think about mutation testing? Like you mentioned, Nenad, that you can sort of get an idea of how good your tests are as a developer, but like, yeah.
I guess if we're just trying to give developers general ways to improve, I would keep it as simple as possible to make the lives of the auditors easier. Because we can definitely try to turn all developers into auditors, but that's a pretty big ask. If we can just keep the developers doing the developer things, but doing it better, and the auditors doing the security things, but doing it better, that almost seems like an easier way to divide the responsibilities. So if I'm going to beg developers to do some very basic things, it would just be do things like have clear NAT spec. You wouldn't believe how many contracts still don't have good NAT spec before going to an audit. Seems simple. A lot of people can't meet that simple barrier. Even using clear variable names. I feel really bad doing a security audit and then suggesting better variable names because it really just doesn't seem like that's my job. But when the variable names make no sense and sometimes are completely misleading, it really just makes the audit process harder. So I would even say those two simple things, good variable names and clear NAT spec, I would just beg developers to do. Mutation testing, amazing. But again, this is like one of the more advanced things that you'd have to make sure you're setting it up properly, making sure that you actually have an end goal for why you're using it. If you're using some of these security tools and you have no idea why you're using it, you probably shouldn't be using these security tools. Leave it for someone who actually has used them before and can more easily set them up and actually knows what the output should look like and how to deal with the results.
Okay. One of the, I wanted to add some of the basics things that we didn't cover. Like most of these things were, I would say, a bit more advanced, but using the libraries that have been audited before, for example, Open Zeppelin libraries that have been audited for the last 5 or 6 years. Using those instead of writing your own is much more safer and much cleaner for the auditors when they're looking into it. So that's one of the things. And then looking for the previous hacks, what were some of the pitfalls that the developer usually fell for, like making sure that your code is not vulnerable to one of those malicious attacks.
Also, very dangerous, I think I saw it a few times, is using an Open Zeppelin contract, which is kind of the standard, but it's changing one or two small things.
Oh, yeah.
That's something that's really dangerous, and people should be really hesitant of doing, only if it's really necessary, and obviously you need to notify the auditors and kind of be aware that you change kind of the whole, the auditors now need to audit even that really solid and audited code, even if it's just one line.
Yeah, I mean, honestly, a big issue is when you start chasing some clout with your project and you're like, oh yeah, we made this totally unique thing, and you just took Uniswap and you renamed it all to whatever swap, and now you introduce 70 new bugs because you messed up the search and replace there.
Yeah.
So good job. You took a good library that you could have just imported and you made a mess of it.
Yeah.
Okay, regarding mutation testing, I have an ace up my sleeve because my sleeve. Because actually, there's a researcher from, and this is going to be continued on the next topic, but there's a researcher in the University of Colorado, and she, last week, updated a tool called Sumo, which is Solidity Mutator, and it's bloody easy to set up, 20 minutes to set up with learning how to do it, and then another, between 1 and 10 hours to run the test, but it's just passive running. And it really gives you good quality score of your tests. So the reason why we're mentioning tests a lot is because you need to know what you're building, right? You need to have good requirements, good technical requirements, and then you get to tests. And these tests are validating stuff. And mutation testing tells you if your tests are actually validating stuff well. Because what happens, okay, we have an audit, and we talked earlier, engineer, like, the audit checks the current state of things, but what happens in the future?
Yes, unfortunately, a lot of contracts have certain variables that can be set by the owner, and sometimes when you're doing the audit, you have an assumption that, okay, this value will make sense when the owner sets it. And then when you look on chain after the code is deployed, you are shocked, because in fact, that assumption was completely wrong. So doing mutation testing to check for these values and to see if there's preventative measures to avoid the owner basically shooting themselves in the foot by choosing a wrong value, that is definitely useful. And I will say regarding this new tool released a week ago, the ideas I mentioned earlier, using good variable names and NatSpec, that's like 3-year-old advice. Like anyone could have told you that a long time ago.
Yeah.
But this space moves fast. The tools are getting easier to use. There are new tools all the time, as we see. So definitely, if you're already someone who always writes NatSpec, first of all, thank you. But I would definitely recommend trying to keep pace with other tools and the latest in the space, because as we see, it changes so fast, even I can't keep up with it.
Yeah. Okay.
Yeah, I do have a question, given that you guys are auditors. You mentioned like the owner can change a variable and that kind of messes up the whole thing. When you audit a contract, do you actually like after the let's say you're auditing something that's not deployed, and when the audit finishes, they deploy it. Do you actually check how they deployed it? Because I know there were quite a few really large bugs where the code was well, but they didn't like call the initialize function or something like that. Do you guys, as an auditors, actually do check the deployment after the audit is done?
So usually when the audit is happening, this is before the code is actually on the chain. Because you want to avoid putting code with bugs on the blockchain. That's obviously ideal. You don't want money in the contract, and then you do the audit and you find it's all ready to be hacked at any minute. That's terrible. I will say sometimes what I've seen some protocols do is they will do an audit, they will deploy it on chain, and then they get another audit. And I have to say the scenarios where I have done an audit where the code is already on chain, and I can actually use like Etherscan to query variable values that are set by the owner or in the constructor, I have found bugs that I probably would not have found if I was not able to see it on chain. So normally, we are not actually looking at the code after it's deployed on chain. It's definitely valuable to do so. If any of you are auditors, that's my little piece of alpha to consider the difference when the code is on chain and to use that information when you have it, when you're doing an audit.
Mm-hmm. From our side, we have like as a hard element of the audit, deployment scripts. So we require everything to be set in advance in the deployment scripts, so the system can really fully run and fully be tested, and nothing is going to change. So we have a bit of a higher confidence interval there, but there's always cases where people change stuff afterwards.
Yeah, for example, like even Compound Finance or Aave, they are regularly changing their market parameters based on market conditions. So the deployment script values might look great, but 1 month later they change values in a compound fork, and it's a different story, unfortunately.
Who should take the responsibility for this, like on-chain monitoring?
Great question.
Yeah, I think that's a gray zone right now. That's why I actually like asked, because as somebody that's building in DeFi, we actually like see quite a lot, like you mentioned, Compound and Aave. Obviously, they update their protocols, and a few times the updates actually mess something up. So there's obviously then questions like, should the update be audited? Of course, but it still happens that like I kind of think like there's probably like an auditing firm. I guess the larger companies have like contracts with auditing firms, which is kind of continual auditing, continual kind of security advisement. So I guess kind of that sort of setup where a company would audit the code, they would know it well, and then kind of have some sort of arrangement where they would kind of actually periodically like check, I guess, if the deployment values are working correctly in that scenario. But I'm not sure even if that's kind of the.
I mean, that's the ideal case, but in case of a hack, two entities take the fall: the project and the auditor.
Yeah.
So, who's going to do the monitoring?
Yeah, I'm not sure. Maybe Tenderly.
Maybe us. Yeah. I do have a question for the auditing guys. So we've seen the rise of the new EVM chains that say that they are EVM compatible, not EVM equivalent. What that means is basically that the execution might not be the same. It's just that the interface to the client, to the node, is the same. And we've seen like bugs occurring on these EVM compatible chains that are actually like working on the, for example, Ethereum mainnet, but not on some L2 networks. What's your approach in detecting these? Are you going like really down, not just on the level of the Solidity code or down to the VM and actually checking if the code is compatible with the virtual machine?
So I mean, for every different system, you have its own guidelines. Like recently I held a talk on Venom, and it's EVM-ish, but because it's asynchronous, it has a completely different set of bugs. For example, there's no reentrancy, hooray, but there is a ton of other stuff that due to asynchronous blockchain stuff. So you just sort of, I consider it a different audit, you know, a different technology, and that's it. You're approaching it as a completely new thing. You see some similarities because it is code, but you have these blockchain-specific things in mind at all times when auditing, and that's it. And these will be provided by like company knowledge, documentation, because the guys writing it will usually know a bit about their own bugs and like special cases, and maybe the L1 teams if your company has it, because those guys are going to be more versed in that low-level stuff.
I will say one thing I am now in the habit of doing every single audit is asking at the beginning, which chains are you deploying this to? Because if you are deploying to Ethereum and also some L2s like Optimism and Arbitrum, they are not the same. There are some differences. As a very simple example, block.number is useful on Ethereum mainnet, but on the L2s, Arbitrum and Optimism, it's recommended to use block.timestamp instead. You can look in the docs for the exact reasons. Optimism and Arbitrum both mention this. But just understanding the differences between these different chains is difficult, especially when you get to the less common chains, because you have to specifically seek out what are the differences. It's probably not going to be identical. It's hard, especially because sometimes the chains themselves are updating. Like the L2s are sort of regularly being upgraded, so we don't know exactly what all those changes will be in the future. We have to keep up to date.
Yeah, I mean, what even is a Solidity auditor, you know, at that point?
Yes.
EVM auditor. So would you recommend, for instance, if our project is on Ethereum mainnet, Arbitrum, and Optimism, and we want to move to Coinbase maybe, or to ZK Sync or something like that, would you then recommend basically doing another audit just for the like ZK Sync deployment, which might have a few kind of core differences there?
If in the original audit you did not specify ZK Sync was in scope, probably yes. And I would say that's especially important if you're using one of these chains that is so young that they are getting a lot of updates. Because, I mean, ZK Sync, I'm not even sure how many projects are deployed on there now, but I can guarantee that in 6 to 12 months, the chain will probably have some upgrades to it. Which that's even a scary thought. If you did get an audit for a ZK Sync project today, in 6 months, do you need another audit? Even though you didn't change your code, maybe the chain itself changed. It's a little bit scary.
I mean, even the Ethereum mainnet can change, obviously, like removing the opcode like self-destruct, that may be affecting your code. So yeah, it is kind of scary. Also from like a developer like app side, it is kind of hard to like any sort of new chain deployment, any sort of upgrades, any sort of, like you need to do an audit, then you contact the auditors and they're like, okay, see you in 3 months. So it's kind of hard from like a developer perspective. We know like, yeah, we should get like any changes should be audited and so on. But then in practice, you're like, okay, now do we wait like 3 months to release like a small feature? Like, is it okay to deploy on a new optimistic L2, or do we need to wait for 3 months to get another like expensive audit? So it is a bit hard to kind of, well, like we mentioned earlier, kind of balance between like security and then kind of business requirements.
Yeah, that's tough. I mean, honestly, from a businessy perspective, I think for a re-audit sort of where you're just not really changing anything and just checking any additional parameters for the chain, it's not going to be very expensive. Like, you're probably going to get it for a few percentage points of the original audit cost.
Right. I mean, we also had like issues, I mean, not issues, but if a lot of time has passed, even if we contact like the same auditors, they're like, well,
Oh, yeah.
now like the person that audited your code isn't working here anymore, so we need to re-audit everything, even though it's maybe just like an additional contract which doesn't really move a lot of functionality, but we need to re-audit everything and then like audit the additional stuff as well.
I mean, that depends on the company process. Like, we internally have a structure with auditors and a lead auditor. And honestly, I mean, I've been in this company fairly consistently, and the same audit after 6 months, I'm the constant.
Okay.
So that's in general how it works in terms of project memory. And honestly, you do forget the project after like 3 months anyway.
Yeah.
So it doesn't matter that much. Okay, we have just a little bit more time. What should we finish up on? I think something more positive. We've been talking tough topic, we've been talking dark stuff here. What's a positive outlook for security? Like 3 days ago, news, 70% less money stolen. Come on.
Yeah, or what excites you in this space for the security side of things? Let's see. I'll let Wendy.
I would say comparing to the like landscape 5 or 6 years ago, the quality of the code overall on the mainnet for the deploy contracts raised quite a lot. We have, like, as you mentioned on the previous talk, we have certain like steps to ensure that the contracts are more secure, that there are no like bugs that have been like in the past and that are like constantly repeating. Hopefully, we're going to lose the reentrancy bug in the future completely. Well, yeah. So I would say that the space is evolving and maturing like much faster than I expected.
Yeah, I definitely like just looking for an application sign and like following different hacks that happened. I think we kind of now have like things that were new a few years ago now are kind of like standard issues you should kind of worry about and kind of know that like, hey, like price oracle manipulation is possible, reentrance is possible, and so on. So as a DeFi developer, you do have like a kind of a checklist of stuff that you already know that. So even the like most kind of quality teams, like even if an issue arises, it's usually something like way more complicated. Like the simple issues, I think, like in DeFi are kind of starting to go away. We kind of learned in the past 3-4 years, like what are the common exploits and issues. And I think kind of going forward, it will be kind of even more like not standardized, but I was just talking like to Nebojsa beforehand, like in Web 2, like in the beginning, like simple like SQL injections were possible. Now that they are much less likely. I think like in general, like reentrances were a big thing maybe 3-4 years ago. Yeah. Now much less because everybody's aware of.
Yeah, everybody knows the check effect interaction pattern.
Yep.
I think a really positive thing is like the scientific contribution, and there's been more and more tools and more highly qualified people in the space, you know, adding stuff like symbolic analyzers, which require tough to design circuits to detect stuff, and they're doing that, and that's now something you can just use. So it's really easy, and it's a great addition. And you, engineer?
Yeah, I think just the awareness and prioritization of security in the space has improved a lot. And yeah, there's still a lot of problems with security in this space, but we are moving forward. We are maturing slowly. It's not going to happen overnight, even though I really wish it would. So we're moving in the right direction. It's slow, but we're getting there.
Yeah. Well, that is it from us. So it has been a pleasure talking to you guys about security, and I hope you all been informed about some useful things.